So yeah, I'm Florian Douetteau from Dataiku, and so I wanted to share with you today some thoughts about the solitude of people running data teams. And so just to give you a little bit of context here, so my work with data has not been so straightforward, meaning when I was 20, I must admit I had quite a nerdy background, meaning I was more into type system, programming languages, compilers, VM, NLP, graph analytics, and so on. So, and I was mostly running Emacs, but sometimes switching to Vim. So, to sum it up, I used to hate graphical user interface. And so, the thing is, today, we build a software which is kind of a glorified visual development environment for data teams. So, and it has visual everything, meaning visual data preparation, visual machine learning, visual workflows, and so on. So I keep asking myself, how did I fail so low? Why did I need visual everything? So I will tell you a small story that relates to that. So actually, that's the story of a guy. Let's name it Al alone. And so imagine Al as kind of a manager for business intelligence at a mid-sized firm running e-commerce. And so maybe he's been here for the very beginning of the company, so maybe he's the manager of a team of one, hence his name. And so one day, his boss, Dim, come and say to him, hey, Hal, I've just been to the golf course and talked with Paul. I really think we should do big data stuff like all the big players in the field, because that's really key to our company being competitive in the next 5 years. So yeah, and so yeah, deal is probably right. He's 100% right. But then Al is asking himself, oh, will I do that? Or I'll actually do big data. What do I need to do? Do I need new tech, new people, new technology, how to organize the project, and so on. And so that's how he starts scratching his head, actually. And so first question for Al is, well, what kind of technology stack should I choose? So in order to do that, he will start going to conference like the Hadoop conference, Hadoop Summit, and so on. He will start going to some meetups like this one. And then he will soon realize that maybe he has like 6, 7, 8 big fields, like machine learning, real-time, not real-time, SQL, no SQL, storage, statistics, and so on. And for each of those, there might be like 6, 7, 8 good technologies to choose from, and most of them are free, of charge, or even free software. And so that's not like 7 times 8, meaning 56 possible combinations. An architecture, it's like 7 power 8, which is more like 5 million possible combinations of architecture. So that's a lot. So you need to choose a technology stack out of these 5 million of combinations. Then he starts hearing some horror stories of companies that started to install Hadoop, and it was not working, it was too slow, not responsive enough compared to SQL technologies and so on. So soon he realized that in order to make things work, he would have to invest a lot in technology, meaning build possibly new hardware, hire good people, or build a prepackaged or cloud-based software to manage his infrastructure. Then, as he starts having a basic infrastructure up and running, it starts entering into the politics of big data, meaning he might want to go into Python, but discover that the statistical team somewhere will do some R, in fact. He might want to do everything in Spark, but he would find out that maybe the geoanalytics team in the company is really into Postgres and PostGIS and want to do everything in Postgres and PostGIS. So here he has to take a big decision. Does he want to be a polyglot, meaning assume that he will have a huge variety of technologies inside his stack, or be a dictator, meaning impose a doctrine in terms of technology? And so possibly both are fine, I think, but he really need to choose, because you cannot really be a polyglot dictator. It does not exist. Then he starts also worrying about putting things into production and to the operational side of things. And here, if we took just a step back, last decade, people that were really, really good at winning the war of website, social, search, content, and so on, were companies that were really, really good at releasing website and software, meaning they even invented a new culture around that. So it might be that in the following decade, where everything will be about having intelligent connected devices, companies that will win will be companies that will be very good at putting predictive models in production, putting intelligence in production, which is, I think, today still an open problem. So as it starts having like an actual technology stack, soon it becomes a people problem, as usual. And so, why so? Well, it's because Al first need to decide whether he wants to build his data team as an extension of the existing business intelligence team, or like build it from scratch. Well, whatever happens, he will need to add new roles within his data teams, like a business data analyst, data scientist, Hadoop engineers, and so on. And they will have to live with the continuous flow of business needs and the existing IT constraints, obviously. Okay, but the key thing which each and every one of human resources problem is to manage expectations. Meaning it will hire people with job titles as data analyst or data scientist, but, well, I guess that many of you have actually worked in data teams. Your actual job could be different. Like, and the question is, how we will be sure that these data scientists won't be data cleaners or data plumbers or just keep waiting the end of an Hadoop job and drink too much coffee and speaking too fast. He will also have to manage extreme personalities, like this famous data scientist. I'm a data scientist myself, kind of, so. Meaning I don't know. Meaning usually they think they are highly creative and passionate and ambitious, but it means that they are hard to hire, hard to retain, and they might want to take his job, which is actually a big problem for Al. On the other end, you have this question of having data analysts, which are more like the people fighting the entropy of data and fighting the patterns in data, and the engineers, more into the make things work mindset. And so the question is, for him, will he be able to make those two work together? And so a question for him is, will he rather have analyst, engineer, and data scientist working together, which is an interesting idea, but with a huge implication in terms of collaboration, or having a uniform team of data scientists? In my perspective, well, whatever happens today, you must be able to make the two mindsets coexist. Meaning when you work with computers today, you have people which are more into the coding kind of mode, meaning a textual interaction with computers, and people which are more into a visual interaction with computers, the clickers and the coders. And you must be able to make those two work together, meaning the clicker must be able to prototype things quickly, generate perhaps some code that the coder can use as a starting point, and the coders must be able to package whatever jobs they do in building blocks that other people can reuse, more or less. Then, let's imagine that Al somehow managed to have some tech stack and to hire a team, so he really needs to start working on data. And so the thing is that I did not really make the stats, but I think the main reason for a big data project to fail is not having the data. Meaning you start the project, but like 2 weeks after you realize, oh my God, we don't really have the data. And so I really like the kind of technology side of things, but I must admit that in real life, when you do have the data and you do have the real business problem you want to solve, it's like you already did like half of the job. And so maybe you spend like 30% actually working on the domain-specific or problem-specific features you need to build, and the optimization part of things, the algorithmic part of things is only maybe 20%. So, question is, how to get data inside your data team, data hub, or data lake. I usually think about 3 strategies that I like to name after animals. The cicada strategy is about being optimistic. I will explain later, maybe. So it's all about thinking that data will be available as open data or within some central open hub within your enterprise. So it can work if it works. The spider strategy is about investing into a set of trackers or APIs that you will make available. We'll have a nice feature in order to make people use it and provide them with your data. So it's a pretty interesting but costly feature, costly strategy. And the fox strategy is about hunting big. And here Al would go and see the CEO and say, I can solve your biggest problem. Give me all the data I need and a budget. And so we will use that as a bootstrap in order to get more budget and more data. And so it's a pretty effective strategy, a little bit devious, meaning basically we do that in order to eat the budget of other teams within the company. And if he's a startup, he will do that in order to sell a model he's built to competitor of his initial sponsor company. So, last but not least, once he has data, a tech team, a tech stack, and a team, he actually needs to do things. And here again, if we take a step back and ask ourselves what big data is really about. Like 5 years ago, big data was all about having Google being able to predict the flu ahead of time, like 2 weeks or 3 weeks ahead of time, by analyzing search logs to predict when the flu will actually happen. And so it was all about visualization. But at the same time, we all think that today, in the next 5 years, it will be able building this network of smart, connected, artificially intelligent devices that maybe will all have a small predictive models in it and be able to retrain themselves or whatever, do mystical things using machine learning, which is another ambition. But maybe like it's awfully close, like maybe we are only 5 or 10 years away from this world of integrated and smart devices. And so Al really needs to position his team in this particular mindset. Meaning specifically, it's not just being able to having more data to get more insights, but he needs to build data and get data and build any products he do to actually automate decisions within the company. So in my perspective, in order to do that, a data team must be kind of close to the product team, meaning he really needs to have either someone with a product management mindset, either in the team or very, very close to the team, because any significant data science feature you build is actually a feature, meaning a product feature, and you can't really build a model if you don't think about the feature first. Then, in terms of strategy, I think Al really needs to kind of understand where is the added value of his data team. Meaning you've got many data science problems you can solve, but the thing is that for many of those, there might be another group or another company that is better positioned as yourselves to solve it. Meaning, for instance, if you take like marketing channel optimization problems, it might be that any startup company solving it globally have more data, and so a better model and better way to actually solve it. So you don't want your data team to focus on these kind of problems. You want your data team to focus on the problem which are core to the business of your company and solve them. And last but not the least, if you really want his data team to be successful, he needs to create a kind of API culture within the company. Meaning a culture where, well, it's so common to have data teams sharing results through emails, flat files, copy-paste of codes over emails in order to put things in production or stuff like that. But that works, but that's not a way to build great things over time. And so he really needs to enforce a way to build reproducible, documented workflows, to have clean APIs for everything, kind of, to actually build products. So, to wrap it up, I don't have a solution for Solitude of data team managers. But it might be that Al can find some solutions. He can be a polyglot on top of open source. He can find a way to have his clickers and his coders work together. He can hunt for a big problem to get his budget and grow his team, and so on. And that was kind of the romance version of why we started and why I started to work on a software for a collaborative software for data teams to actually enable teams with clickers and coders to work together on top of open source technology. And so, will that work? I don't know. But I did see over the last 2 years many companies starting new data teams, either from scratch or reinventing themselves through data. So I really think it's possible. And that over time, all those new companies will actually create the innovation of data science, which is today, innovation of data is usually concentrated among a few numbers of digital giants. But I definitely believe that in the next 5 years, it will be many companies that will create this innovation. And what I really hope is that they won't leave their own HAL alone or by themselves. And thank you for your attention.
Thank you very much. Just one question from me, because I want to leave more time for people to ask questions. So you very kindly did not spend too much time just pitching the company very hard, but you mentioned it at the very end. Tell us about the company. I guess that's your opportunity to do so. When did you guys start? What's the product actually like? How do people use it?
Yeah. So yeah, we are a software company, and so our product has been on the market for 2 years. We are based in Paris and New York. 55 people in the company. Well, the core concept of the product is to have a unified data science platform where you can have data management capabilities and machine learning capabilities. And to have, well, those two kind of key capabilities fused together in the same software.
Okay. And so you connect to all sorts of underlying sources. You have a library of connectors, and you...
Yeah, we have a library of connectors to open source storage and software, and also connectors to machine learning libraries, so that you can choose whatever machine learning libraries you want and open source storage you want for your data project.
Okay, great. And the product is for data scientists and data analysts. A little bit to this. I mean, what level of technical abilities do you need to have to be a user of the product?
Well, you must be into data. And typically a data analyst would be someone which is already into visualization software like Tableau, Click, or this one, and which is by need, he needs to move into more kind of a kernel relationship to data, because he needs to do some data preparation, he needs to build some segmentation model in order to get some ideas and feed his own thoughts and so on. And so that's the typical users of our software as data analysts. And usually we have teams like where you have like a mix of data scientists and data analysts.
Okay, great, thank you. Let me open up to people. If you have a mic.
Hi, how are you? Very quick question. Who do you consider your main competitors?
Oh, that's a good question. I consider my main competitor to be the SAS Institute, and meaning actually that's the company I want to replace, because I don't like SAS. Sorry if you're into SAS. That was a quick response.
And do you find that people tend to want to build their own stuff internally as well? I mean, is sort of homegrown a competitor? Homegrown?
Yeah, well, large startups, especially large companies in the Bay Area, tend to build their own stack. And they typically build their own stack if they started big data like 5-6 years ago. They build their own workflow or ETL solutions. But that's not our target to actually sell our software to LinkedIn or Facebook, typically.
Great.
Yes, I see that you had the AXA logo up there on one of your slides. Maybe you give us insight into the mutual business agreement there.
So yeah,
what's going on between you and AXA?
AXA is our customer for about 2 years, I think. And so they are using our software internally in their data initiative. So yeah, we have about 30 seats of at AXA, 40 users at AXA, I think.
Sorry, is that a standard number? Meaning, one question to as a VC, when I look at a business trying to sell to data scientists, the question is always how many seats within an organization you can sell. So it was interesting to hear that you also sell to data analysts, not just data scientists. But any thoughts on that? I mean, how I guess what is the average size of the potential target in large companies?
I think that in large companies you have potential targets of few hundred people, actually. Because many companies have the vision of having like data analysts, largely speaking, moving from a SQL and possibly SAS world to a kind of Hadoop-ish, Spark-ish world on the long term. So that's the vision that many people have, hence this number of a few hundred.
Great. Do we have one last one over there?
Hi. Just now you mentioned that one of the challenges today is to deploy the models. So to you, what's the key to solve this problem?
That's a fair question. I think that today you've got many issues to solve, like at least 4 or 5 big issues to solve. I won't list them all, but one key aspect is just from a technical perspective, maintaining the versioning and consistent environment when using data science tool is not so obvious, because you've got a complex stack with Hadoop, Spark, Python, possibly R, and so on. That's one issue. And a second issue is that you need to learn what release do mean. Meaning, what is your package? What is your deliverable? What is the process for rolling back? Who will do the monitoring? What would be the role of the guy doing the monitoring? An actual challenge for companies that we saw is that you have the data scientist doing a few projects the first year. They might have like 1 or 2 projects going to production. But so the thing is that if they have on the second year to maintain the projects they built in the first year, they will stop delivering new projects. And because you cannot hire more data scientists, data scientist is a very well-paid job. If you are not into data science yet, you should. Then they just cannot scale the team and scale the actual value created by the team. And so I think a challenge would be in the future to have like specialized people for operations on data that will need to understand well scalability issues from a system administrator perspective, but also what F1 score is, because they will need to be smart enough in order to understand the monitoring of complex system where you would have possibly multiple models running together and being retrained and updated automatically.
All right, wonderful. That's the time we have. Thank you very much.